So, last assignment, the last thing from this particular chapter. We've got a test next week, Tuesday.
Oh,
A what?
Test next week, Tuesday. Okay, last assignment from this chapter.
Actually,
No, she's lying.
Our
No,
Carol
it's on
wants
Monday.
dinner, came Monday.
Sarah's actually
Monday,
with it.
Tuesday.
It's on Monday.
No.
Yeah, Monday.
Okay.
Happy
It's on
birthday.
Monday.
So, here we go. Here's a few vocab words for us.
Did you get Instagram?
I opened one because I wanted to see what it was, and then saw what it was, and thought it was stupid, so I got rid of it.
Why did you make it?
That's why I just follow CNN and make fun.
Why did I what?
Oh.
Now they have most followers.
Oh,
Your what?
I said your
Okay. Theoretical yield, actual yield, percent yield. Theoretical yield. It's the maximum amount of product that can be created from a given amount of reactant, aka we've been figuring out the theoretical yield this whole chapter. All the stoichiometry math that we have done this chapter has been figuring out the theoretical yield. What I mean by that is, if you went into the lab with these correct amounts of masses and you did the reaction, if everything went perfectly, the math number that you get would be what you would get in the lab if everything in the lab went perfectly. What do I mean by perfectly?
no error.
No error. Okay, do you think that happens very often? No. The actual yield is what you actually get in the lab. Okay, so for example, I go into the lab, I do a chemical equation, and I get 40 grams of a product. When I do the stoichiometry, I should have gotten 45 grams of the product. Okay, so what the percent yield would be, here's your equation for it. So you're going to have to write this in.
It's actual.
It is your actual yield divided by your theoretical yield. Okay? Let me give you kind of a big picture of why and where this is useful. When I worked at Chem Industries 2 summers ago in their lab, and I can't tell too much from proprietary reasons, but basically what they had me do is do a whole bunch of experimentation on trying to purify one of the things they sell, because they wanted to be able to put it in some other product and it had too much mass to dissolve, and so they wanted to purify it so that it would dissolve easier, or would have less mass to dissolve. Yes?
The one with that space.
What?
Is it the one with
Yes. The one that you drive by in MLK that was brand new.
like?
Yeah. Anyways, so I was charged with being able to purify it, but at the same time, I wanted to make it more pure. I also had to have a really high percent yield. Why do you think they wanted me to have a really high percent yield?
More product.
Okay, kind of.
More theoretical.
Well, theoretical is always the same every single time. So basically, I had to do all these experimentations to increase the purity. Basically, there was a certain amount of mass that they could get 30% of what they wanted, and there was 70% of some unknown stuff that they had no idea what it was. And they wanted to make it go up to 60% what they wanted, and 40% what they didn't. Okay? But believe it or not, it is very, very difficult. Most of the time, when purity goes up, percent yield goes down. Okay, let me explain why. When you're trying to purify things with a lot of the purifying mechanisms, whether it's using a solvent wash or going through a filter or whatever, you filter out some of the bad things, but sometimes you also filter out some of the good stuff. Does that make sense? And so what was happening is a lot of times I could get it to be more pure, but I would lose some of the yield. And the reason why that's not okay is great, I can make it more pure, but if I'm losing 20% of the stuff they're trying to sell, are they gaining money or losing money? Losing money. Okay? Now, believe it or not, it's way more difficult than maybe it sounds, but what I was charged to do is be able to purify it, make it twice as pure, but still maintain a 95% yield. AKA, I can't lose a whole bunch of stuff just to make it more pure. Because making it more pure doesn't mean you have more stuff, it just means you have less impurities. Does that make sense? If I take something that has 50 grams of what you want, and you make it so that you have it more pure, but you only have 40 grams of what you want, you're losing money. Does that make sense? Sure, you can't put it into some other products, but you're losing product. Okay? Now, I was able to achieve that goal in 6 weeks. However, never as simple as simply just doing that, because from a production standpoint, there's a lot of factors that go into making a decision. Because I was able to purify it and maintain a high % yield, but I did it with using a flammable solvent. And you can imagine, believe it or not, that if they want to use a flammable solvent to purify something, they have to build a flammable safe plant. And then they have to go through all the safety regulations that they have to make sure that the flammable plant, along with the product being used to, or the flammable solvent being used to purify, is that safe for ingestion. And so now we're talking lots of money going into that. So it's never as simple as one little thing, and my eyes were open quite a bit to the reality of the big business world. Now I don't know, I haven't talked to them since I left. I don't know if they kept pursuing that or what they ended up doing, but I do know that they were very happy with the results that I had come up with. And so % yield is very important, because if your % yield is low, you're losing money. Does that make sense? So what we're going to do today is we are going to calculate the % yield. This is examples. This is not, we're not doing this real life here. Okay? So remember yesterday I said when you have two masses, it's always limiting reactant? Well, not always.
Told you.
Here's what I mean by that. Context is still key here. Okay, so if we read this, it says aluminum hydroxide is found in many antacid tablets because it reacts with hydrochloric acid. Do you know what an antacid tablet is? What do they take those for? Do they? Heartburn.
That too.
Right? An antacid is an anti-acid. What do you think that does?
Anti-acids.
Yeah, what do antacids do?
Calm down your acids in your body.
They neutralize the acids in your body. Essentially, when you take Tums or when you take whatever heartburn medication, you're basically putting a base into your body so that it will neutralize the stomach acid in your body. Okay? It's a big misconception. Most people think you can get heartburn from eating spicy food. That is a lie. Do you want to know why? How someone gets heartburn?
No.
They overeat. And so their stomach gets full. And the hydrochloric acid, which is infinitely more damaging to you than the spicy food you eat, from your stomach, the hydrochloric acid from your stomach, starts raising and getting into your esophagus and burning your esophagus. Hence why it doesn't feel very good. Okay? Think about this. If you ate the spicy food and it didn't hurt going down, why would it hurt coming back up? You ever think about that?
What the dust report?
What?
What the dust report?
Then you got other problems. Does that make sense? So really what happens is you filled your stomach up so much that the hydrochloric acid that your stomach needs to break down your food comes up and raises into your esophagus and doesn't feel good. So, anyways, fun little fact there for you. Munch on that. Can you what? You're bleeding?
No. Need that.
Okay, let's quick fire do this chemical equation. Aluminum hydroxide. You guys remember how to write these? Aluminum has an oxidation number of 3+. You guys remember what hydroxide is?
OH negative.
Okay, 3, 1, crisscross down, voila, yeah? Okay, hydrochloric acid, that's HCl, goes to produce a very, very, very non-hostile salt known as aluminum chloride. 3+, 1-, crisscross down, correct, Nuno?
E.
And H2O. So we're taking nasty stomach acid and turning it into a salt that doesn't do anything and water that's not bad for you. Makes sense. Okay? Next we're going to balance it. Okay? Alright, now let's read the problem here. It says if I got 15 grams of my Tums, I call it that, I don't know if that's really what Tums is made up of, but okay? It's found in a single tablet. Determine the theoretical yield or the stoichiometry math, or in theory, how much acid you can neutralize and how much aluminum chloride would be produced if you had excess amounts of hydrochloric acid. What is excess trying to tell us here?
Leftover acid.
Nothing to do with it's going to be leftover, yes. But why did they give us that? Why did they say that?
There's a limit.
This is the limit?
No, that's not.
Oh, we have plenty of this in our stomachs. This is our what? Limiting reactant. So thankfully we don't have to figure out what the limiting reactant is. We already know it. That's what the excess tells you. Can't see over there, can you? Yeah, it would be real wise for you to not sit there every day. Hey, Mr. Andrew.
Yeah.
I want to sit up.
What?
Huh?
No, just
We are solving for what?
aluminum hydroxide.
I think I've heard 2 answers and neither of them right.
Hydrochloric acid.
Oh,
What does it say?
I don't know.
Determine the theoretical yield of?
I literally said
Alright.
Yeah, but I don't listen to these now.
Really?
Okay,
That's why you said I'm walking out of this class. That's why I said I think I heard
I'll accept this. I'm walking out of class. Hate you, Andrew.
Wait. I was the one who said it.
I know, it's, I just have to tell him. I tell him I never did.
Who?
Yeah, I don't like him either. Alright.
You know what? I'm walking out of this class.
Okay.
It's a long video.
Grams of what? What did I say? Aluminum chloride?
Sorry about that.
Yeah. They can fire me.
What do you want me to say?
I'm not afraid. I'm a commodity.
I do.
I'm a liability.
I'm not going to have.
I can say whatever I want because you can't replace a science teacher.
I'll replace you.
Because there's hardly any of them out there.
Stoker.
That sounds bad.
That is
But I'm probably me and Mr. Saver are probably the most irreplaceable teachers here.
Yeah.
Not because we're good or anything, but because there's very few science teachers in the marketplace.
Mr. Fisher.
You know what I mean?
Mr. Fisher.
Yeah, it's hard to replace him. He just is like a cancer. Just keeps coming back.
You roasted 2 people in class, and you just called Mr. Fisher cancer.
So
That's all I
Shout out, balls like
I did not know. I never. Well, kind of. I did kind of. I love this movie.
Okay.
Oh,
Okay, can we do this problem?
Yeah, we're good.
Yeah. Gosh, you guys get off track. Come on. Alright.
What word? Grams of AOH3.
Okay, I'm assuming you're good at this now, right?
The best in the business.
Molar mass, bookend molar masses with the mole ratio right in the middle.
26 plus 48 plus 3.93.
It's like a mole sandwich. It's great.
Okay.
Okay, anybody got that, or I gotta go open my book and figure out?
I got it.
What do you got?
78.01.
Is that right? Have a second. That seems low.
No, because 308, that's 1648 plus
That's
3.08.
1648.
And then plus
27 and 48. Yeah, that's probably right.
yeah.
I just don't want to write a wrong number and be wrong.
I don't know.
Okay? I just want to, usually having a second person amen is good. That's good. Okay?
My aiming myself.
Then, what are we doing now?
Moles to moles.
One. Everything's one?
Yep.
Really?
Yep. Yep.
Wow, that's boring.
Yep.
Is that right? 1 and 1?
Yes.
Okay?
Oh, I'm so weak.
No.
And aluminum chloride.
133.33.
133.33.
Yeah.
Oh, this is new.
Amen, Carly?
Praise God.
Okay?
50.
Oh.
Okay.
Okay. 25.6, and it is 25.64.
Okay, in the context of this lesson, what is that? What did you say?
Here,
The theoretical yield. Okay? The theoretical yield is our mathematical number that if everything goes well, if I dissolve and react this is how much product will be produced. That's assuming that there are no errors in the experiment, which in reality never happens. Okay? Although, so you would think that the theoretical yield would always be less than 100, correct? That's what you would think if you could never be perfect. Okay? But you could also have error in the opposite. For example, you could think that everything reacted, and then when you went to get the mass of your product, what you were really getting the mass of was part product and part reactants left over, and that could give you an actually bigger number. So most of the time it's going to be less than 100, but error can cause it to be more than 100 as well. So this would be the answer to question 1. How do I answer question 2?
So just divide by.
Because this is the what?
Here, choose one, please.
What is this?
the actual.
That's you measure, okay? So you got 23.00 grams of actual divided by what I theoretically should get, and it makes sense that that number's smaller.
89.
Times 100, you should get about an 89 point what?
7.
Which that's not an awful theoretical yield, but imagine losing 10% every time you do something. It's a lot of money. If you could find a way to increase the theoretical yield, that would be good. So that's from a consumer standpoint. You're awake, that's true. Are you paying attention? That's another thing. Oh, it wasn't a rose. Yeah. I feel like I just saw like my 3-year-old child.
Titus.
Oh shoot, she's mean.
You're sitting along with that.
You guys didn't get that one. Alright. Questions?
Why did I get this raggy time?
Don't take it out of your hands. You have other questions? I don't think today's lesson's overly difficult because this stuff,
It is so hard.
we've been doing this for a very long time, haven't
Oh.
we? Hey.
Yes, dude.
Sometimes you just need to laugh at them. But in a good way, I'm laughing with you. want to be laughed at.
Yeah.
You do. I know you.
Candy's laughing at you, Seven.
The only thing new is this.
John
I feel like.
This is a fail of a class.
Sorry. Sorry, Kramer's camera. Shout out Buzz Life.
Shout out to being the worst teacher ever.
Oh my god.